Hello and welcome to this mining tutorial. I am the Performator, co-founder and CEO of Shugo. We operate TensorProx, the world's first truly decentralized edge platform. To be decentralized, we need you as a miner to operate and run a man-in-the-middle node. That is protecting, that is how we start, from layer 4 and 3 DDoS attacks. So the setup to get started shouldn't be the challenge. In order to support you with that, we have dedicated this video to go beyond the commands that we provide you in the documentation and give you the full context of what is going on and what's needed to perform in TensorProx. So let's get started. As we have a look on our website, it's pretty informative. At this point, it's the central hub for all things TensorProx. At some point, it will serve as a client login, but for now, full of information. And of course, we also have some interesting video for you. And yeah, but this is technical. Okay, so let's get to it. We have two buttons here in the center. And the mining dashboard, if you click that, you will be forwarded to dashprox.com. Dashprox.com has three main purposes. For those that are simply interested and want to follow the progression of the subnet, the whole platform, please have a look at the top right corner where we aggregate all the important KPIs over the UIDs that are active to track the growth of the platform in terms of performance and capacity. Okay, and if we want to be a guardian, a respectable guardian of publicly available IPs, we have a lot of room to grow 2 weeks in after the launch, and that is what we can follow here. So that is for all that are more visual. And then the next two purposes of Tensor Dashprox are more technical. So if you run a miner, you might want to use dashprox.com to understand what is going on during the rounds. You need to pass a lot of different steps successfully to have your performance rewarded with scores by the validators. If you fail one step, all the consecutive steps will fail. Okay, failing means status code 400 or 500, while 200 is a successful step. Just looking here, it's preset the UID 22. It is successful in the ping status, but then was failing a lot during the setup, and all the consecutive steps were failing as well. Then in the last iteration of a round, you can see everything was passed. 22 was looking, okay, where do I fail? What is going on? And specifically looks into that step to debug. And then, yeah, most likely all the other steps will be successfully performed. So as we see, the last iteration, it went through nicely, and actually there is a packet sent, and performance was scored. So talk about scores and performance. That is the third reason why we provide you with Dashprox. You can benchmark yourself with your UID against the one that is performing the best. To understand why is it scoring better than you, because that is how we grow. Okay, of course, the best top performing UID will not give you the recipe to perform as well or even better, but you can pinpoint some of your optimization efforts to a single vector and deep dive into what it means to score better here. And that is how we grow as a platform. Yeah, if you put in the work, and that is the nice thing about Bittensor. If you put in the work successfully, you will be rewarded. So that's the name of the game. I guess you know it. That's why we are all here. And dashprox.com is meant to help you with that. First, track the performance globally. Second, debug your miner to really get started. Third, benchmarking to optimize your performance in order to earn. Good, that is the mining dashboard. Let's get to the GitHub. GitHub is where all the truth is documented as code, as we are an open source project, just like the culture of Bittensor. Everything that is going on in TensorProx is here in the GitHub. So there's a lot of text. You can read through pretty much everything that matters, as well as the different parameters that we value and weight in the reward function, but and steps to perform during a round. The important one to get the whole picture is the architecture though. So let's have a look at that one. Whoop, that's the wrong. Let's have put me here on the other side. So this architecture explains why I am talking about a man in the middle. It's just an architectural term. Of course, you can perform and participate in TensorProx in any gender, with any gender. It really does not matter. It's purely architectural, and from this picture you see why. Because we want you as a miner to run a mode node, and it is placed in the middle. It's protecting the target server, which we call the king. So the high level goal is to protect the king. And how is it done? The modes challenge right now is, and later on as well, is to separate good from bad traffic. That is the only purpose of this mode, and on a scalable level. Where does the traffic come from? Well, surprise, it comes from the traffic generators. So there's the possibility to add many of them. Right now, in this early stage, 2 weeks in after the launch, it must be between 2 and 8. One thing, if you're getting started, start with 2, okay? It is not rewarded to have you running your mode senselessly with a lot of packets. This is not gonna raise your reward. It is raised if you understand what is going on, if you understand how to improve the basic architecture that we give you on the mode, and you make TensorProx look good and more mature, so we can grow together. That is rewarded. Okay, so start with 2 traffic generators and do a great job to protect the king. Because at some point we will just change the king to a real target server, and they need scalable protection as well as reliable. But with the overall platform architecture, we will make sure that it is highly available. Okay, but that's not the focus right now. Let's get to it. How do we set this all up? For that, we change our view to the presentation here. These are the most important steps, especially the first ones. And we will have a look what is going on here. Exactly. So first step, create a VPC. A VPC is absolutely mandatory, as we are not creating pictures, we are not predicting the weather, we are not predicting price or doing any other fancy stuff. We are running DDoS attacks, because that is the only way we can really find out if you're doing a good or a bad job. So that is ultra realistic, and in order to save you from any harm, please deploy your machines into a virtual private cloud, which is short VPC. If you start ramming the web with our challenges, you will have a problem, okay? If not today, you will have it at least in 2 weeks, because then even the laziest cloud provider will understand, okay, something is not right here. Someone is attacking the whole web from my environment. You don't want that, okay? You want a consistent journey progressing, and this is why you need to deploy your machines into a VPC. Then it's a closed environment. You are only working with your machines. No one will know what is going on. Another added benefit of a VPC is it does not matter how much traffic you produce. It will not be built, okay? So you can, if you have a good architecture, you can deliver terabits of traffic per second if the architecture works. Yeah, and you will not be billed any cent. Okay, the only thing you pay is the machines. That's another added benefit, but it's absolutely mandatory that you deploy your machines into a VPC. Some providers give it to you automatically. Every machine you start is already part of a VPC based on the location. And for other providers, most of them, you need to create a VPC, let's say in Paris, and then you deploy all your machines in Paris into that VPC. If you have the possibility to tune the security policies, please put them as soft as possible or even deactivate them so there's nothing that we cannot debug any policies that prevent you from delivering the challenge. That would be a pity. Okay, so make sure if there is the possibility to tune them, make them as soft as possible or deactivate. That's what I can tell you about the VPC. Make sure it has enough addresses to deploy many machines if you want to scale up. Okay, next thing. Okay, we said 2 traffic generators. In total, we need 4 machines. Okay, please start with 4. It's not rewarded to go big right from the start. Being good from the start is rewarded, of course, but not the so vector to go big. So, how should we size them? As you might have understood from the architecture, the mode is doing the heavy lifting. It is routing, it is detecting, it is mitigating, and acting as a miner towards the Bittensor protocol. So as a rule of thumb, when you work with 2 traffic generators, please make your mode or provide it with double the resources of 1 traffic generator. So like in this example, if we have 2 cores on a traffic generator, please provide your mode with 4. That works fine. Yeah, and the resources are not responsible for an average performance. Okay, that is all we need to make sure. Good. Once we have the machine, it's time. Of course, you can do it in via the cloud UI or something, but we need to make sure that your machines are connected or that your mode can connect to the workers, because your mode is the central hub, the manager of your environment, and it needs to be able to connect not only on the network level but also via SSH. So that's what we need you to do to establish connection. I will show you how it can be done. I have already created a key pair. The command you see in the presentation, SSH keygen, we can create an RSA key with that. There's also we support also the other way to create SSH keys. It doesn't matter. It's just an example. Okay, so let's copy this command and then run it. So I have created and deployed another key pair, but just to tell you what's going on here. Okay, this is showcase key pair, and let's go. It's prompting you for a passphrase, and I tell you something. No passphrase, okay? You don't want to sit on your PC the whole time and put in a passphrase every time your mode is connecting to the workers. That's not how it should be done. So to make it passwordless, press enter. If you're prompted again, press enter. That's it. Now you see we have a key pair SSH. This is the private key. That is the public key. The public key, it needs to be deployed on all the other machines. Okay, so you go to the other machine's interface, or you do it via the cloud UI when you start the machines already. That all your workers, the traffic gens and the kings, that they have the public key that matches the mode's private key. Okay, we are right here. You see, we are on the mode. So SSH always a key pair, and please put the corresponding public key into the workers. And where it has, there's always in the SSH folder, there is an authorized keys file, and in this file, you need to deploy the public key. Okay, for the respective user. Here it is root, on some other environments it's Ubuntu, or you create your own user, it doesn't matter. Okay, it's just important that you establish the connection in that way. And then if you want to test, it's an easy way. If you just SSH -i, and then we use this key. The private key is used to connect, and the public key is used to authenticate the private key. So if I now go to, that's the tgen in this case, it's root and this IP, then we should be able to connect. Let's see. Yes, here. All right. So you see, we have connected from the mode via SSH with the Hello YouTube key pair, which I deployed before this video on the other machine on one of the workers. Okay, so then we exit again. This is just a test. So you see, they are connected. The mode can connect to the workers. And that is what step number 3 is all about. Okay. Yeah, this is set. And then, yeah, it's time to run the setup. To run the setup, let's switch back to the other scene here again, where I show you how you can find the setup. Okay, run a miner node is one link here on the GitHub. Just follow it through. Copy the command. The second option is you go on the mining tab in shugo.io, and then you can also copy the command. And that is pretty much all you do. We run these commands after we copied them, and yes, press enter. When there's a window pop-up coming up, press enter. That is how you progress here. Everything will be fine. When you create an SSH key pair, press enter. When you're installing, press enter. That is really simple. So the challenge is really not the setup. So here you see such a pop-up, and enter. Everything is fine. Let's proceed. I realized that I was on the wrong scene again, so let's have a look at such a pop-up I was talking about. This is the one. So if anything like this comes up, just press enter. Good. The setup has progressed a lot. While it is doing the last steps, let's have a look at the next step in our tutorial here. And this is very important as well. You need to understand, okay, in order to fill out the environment file correctly, which device, network device, holds my private IP. And the easiest way to find out is IP space A. Enter into the command line interface, and then you see this list here. This is interactive. There's another example in the presentation. It is important for us or for the whole process to understand which device holds the private IP. It's pretty simple. Here, ETH0, you see the entry for 10.0.0.2. That is the private IP of the mode. Yeah, the whole setup is done on the mode. You pretty much don't touch the workers. If everything is deployed correctly, the mode does the magic. Okay, so everything runs on the mode. 10.0.0.2 is our private IP, and it is part of the ETH0 interface. That is the important thing. If you are in doubt about your public IP, of course, your cloud provider should display your public and your private IP. But in case there's any doubt, here you have a nice command where it gives you the public IP of your machine. This is all a prerequisite to fill the environment file correctly. And as you might have understood, every machine you deploy needs to have two IPs at least, okay? A public IP and a private IP. The private IP to transport the challenge, the public IP for validators to connect, lock down your machine, and run the challenge, for example. Yeah. That is the sole reason why we need two of them. If your own setup can provide this requirement, please go for it. We are happy to support decentralization. But yeah, a cloud environment makes it pretty easy. Good. We have found out now this is the device holding the private IP. It's very important that you put this one into the environment file. And this one is an example. Let's paste one that I prepared into our structure. When the setup was running through, we have here the .env.miner. This is the interesting part. I paste it like that, and these entries are perfect to get productive on mainnet, but I want to start the miner on testnet. Okay, so testnet, net UID is 234. Pretty simple, 234, and yeah. Fini entry point, of course, in order to support decentralization, you should run your own subtensor, but as we are just getting started, it's okay to run on Fini. If you're serious about mining, please use your own subtensor. For all the things that are mentioned here in our tutorial, we have a link to the official Bittensor documentation, where you here to help decentralization, run your own subtensor. And if you don't know how to create wallets, how to register and all this, please follow the link here, as you will be led to the official Bittensor BTCLI documentation. So let's get back to our machine. It has the environment file, and then in the environment file you specify all the information for the king and the mode. As you can see here, there is the correct network interface, and the traffic generators are being registered here in the CSV file. Because at some point we might want to scale up to 255 machines ramming your mode. This is a good sign of growth. So CSV makes it pretty easy to handle this. As you can see here, there's a different device. It depends on the provider, okay? Always make sure you find the device that is holding your private IP. It might be that ETH0 is displaying you only the public IP, but then it also holds the private IP. Then just put ETH0. If there's only one device, this is an internal one. If there's only one device, then put this one device. There's no magic. So let's update the CSV with the right entries for the two traffic generators with the right network interface for our environment. This is done now. The only thing missing is to add your specific VanDB key to the .env. I will stop the stream here shortly to do this. And after we did that, it is important to adjust one more entry to the case that we are deploying to the test network right now. This string here is the official subtensor for the entry point for Fini on the mainnet. I have a local subtensor that should work on the testnet. So, and that is it. That is it. We are starting a script that is basically doing exactly what is here. It registers the hotkey and then starts the miner. Setup.sh, and then let's have a look at what's happening here. First thing, it's running the GRE setup to establish all the tunneling to the workers, the mode, king, within the mode to the king and the traffic generators. And in the middle of these GRE tunnels, there's sitting a machine learning model that detects the anomalies in traffic and then detects DDoS attacks. So this is a good one. This is a pretty good error that many will encounter. SCP has failed, return code 1. We will also see, okay, exactly this one. Permission denied, please try again. Guess why? Because this thing here, the root test is not accessible, not available. Why? Because it simply isn't there, okay? I prepared the Hello YouTube key pair. I deployed it, as I told you, on the workers. So we need to specify this on the env.miner. It is the Hello YouTube private key. Okay, save, start this whole thing again. And we should get a little bit further. Running the GRE setup again. There is one line in neurons miner.py right here, line 872 at the time of recording. You can simply comment it out to save quite some time when you are restarting many times. Now you see it is connecting to the workers and everything is successful. Green check marks. Yes, we are starting with Hello YouTube hotkey on the testnet, and there it is. There it is, everything running. VanDB logging is set up, and we are stepping our way to glory. So that is the whole setup with a lot of things happening here, all the context provided that we can think of. If there is more challenges that you might hit, please don't be shy. tell us in Discord. We are a decentralized network, so we need you to be utmost successful, and it is our job to get you there. And this setup tutorial is just the start of a series of content that we will need in order to make TensorProx a reliable force in the web to safeguard any publicly available IP to start with. That is just one use case. We will get good at that, and then many more will follow. So stay tuned and great success on your journey. One more advice, please make sure you have the right tool for the right challenges. Okay, working in Bittensor every day can be very stressful. So you need something to deal with it. Softball, some SUS around, just don't break things. That would hurt. Good luck, have fun, and please, if you have any challenges, collaborate with us on the Discord. See you later.